All right, now we're going to go to the sixth video, I believe, and we're going to start talking about diseases of the myelin sheath. So this is actually going to be on page 440, and you are going to see the deeper insight, the clinical application of the myelin sheath. We talked about multiple sclerosis on slide 1242, which is the same as fibrosis. All right, and with sclerosis, so just the term sclerosis is just how the nervous system heals. Okay, which is not through cell multiplication. It's not your typical regeneration. Um, it's different. So it's like fibrosis. So now, multiple sclerosis. What you need to know is that it is a demyelinating disease. It's an autoimmune disease, and it slows down the nervous system. So for multiple sclerosis, again, we're studying this together. I'm not a professional here. We're just pretty much going over things. So number one, we need to know that it is a demyelinating disease. That means that your myelin sheath is being affected. Knowing that the myelin sheath is what accelerates the command, the actual nerve impulse, then the action potential, sorry. Slowing that down means that you'll have a slower nervous system. So slows down nervous system. Number two, demyelinating disease. Also understand autoimmune disease. That's what you have to know about that. Also understand that the term sclerosis, I'm going to put here synonym. It's a synonym for fibrosis. Another thing, and you're going to actually see that over here. Okay. Sorry. Here we're going to see the actual regeneration process. Step one, you have your normal nerve fiber. Step two, you have an injured fiber. Step three, degeneration of the severed fiber. So you have your muscle cell right here on two, which is being affected. On three, it's shrinking. Early regeneration, you have a high rate of metabolism within the neuron itself, the soma, so it gets bigger. Here you have the axon regenerating, but very slowly. Okay, right here. This is the growth process, is this regeneration tube. This happens at a very slow rate. You have your muscle fibers here. That's actually affected. So this is a motor unit. So you have one neuron innervated by these two muscle fibers, and they're both atrophied. And this is called denervation atrophy. That's when you cut the communication between the actual nerve fiber and the muscle. Then here on step 6, you see the regrowth of the muscle fibers. On step 5, they were already shrinking even more, and then step 6, they're not back to normal, but they're getting there. So on your slide, you do need to know I would just say nerve regeneration process. Okay. This is the slowest I've ever seen my computer, and I do apologize for that. So we're just going to keep just talking through the slides. The next one, 1244, conduction speed of nerve fibers. You have to understand that it's the diameter of the fiber and the presence or absence of myelin that affects the conduction speed. The wider your nerve fiber is, the faster, the bigger the diameter of the nerve fiber, the faster that signal is going to be sent. And if it's myelinated, so if it has that ring of fat on the outside, it's going to be even faster. Slow rate, I'm just going to put slow rate, C-book. I'm sorry, but that's way too long to put there. All right. So I'm going to put here, what are the variables for the conduction speed of a nerve? I'm going to put 1, the diameter, and 2, the presence or absence of myelin. So we talked about regeneration. Oh, so regeneration only occurs in the PNS. It does not occur in the central nervous system. Regeneration only occurs 100%. If it occurs, it will only happen in the peripheral nervous system, not in the central nervous system. If you cut a nerve, brain or spinal cord, it's done. But in the peripheral nervous system, if you harm it, not completely severing it completely, but if you harm it, then there's still a chance. Second, myelin and diameter of fiber. So here, remember what denervation atrophy is. We also need to know what the nerve growth factor is. This would be a lot better if I had a quicker computer. So I might use a different program. So I'm just going to use notes here. I'm going to jump off to a better program just to do this a little better. While it's loading, nerve growth factor is a protein secreted by a gland of muscle or glial cells and picked up by the axon terminals of the neurons. It prevents apoptosis. So your nerve growth factor, your NGF, prevents apoptosis, and apoptosis is the programmed cell death. So knowing that, you're able to pick up and understand that this NGF, this nerve growth factor, prevents the nerve from dying, pretty much, because it lives at least 80 to 100 years, unlike any other cell in your body. So let's see, muscle atrophy due to lost nerve or damaged nerve, right there. All right. What else? That's the conduction speed, regeneration, atrophy, NGF. The synapse is where the nerves meet. So synapse, where neurons meet. Jesus Christ, that's slow. A lot better. The synapse, and sorry about this, this is where your neurons meet. Or where a neuron meets a target cell. That target cell could be another neuron. You're going to go on your slides that you downloaded from Blackboard. You're going to skip 1250. You're going to skip all the way. You're going to skip all the way up to 1274. That's where your synapse is. You're going to go all the way up to 1276. You're going to skip from 1250 to all the way to 1276. And that's where we're gonna meet, and that's where I'm gonna start my next video, which is where it talks about synapses. I'm sorry that my computer is really slow because I'm uploading and recording and doing all this crap at the same time. So I'm gonna put here neuron meets target cell, and that's gonna be the end of this one. Sorry we didn't get too much done.